Today's daily LeetCode problem of the day is shifting letters part 2, number 2381. Sorry for the lack of consistency recently. I have personally been completely dialed in on my new startup called VYRL. VYRL is a content creation assistant meant for creators of short form content like Instagram Reels or TikToks. It predicts how your video will perform before you post it using real data from currently trending videos, and then gives you actionable feedback on how you can improve that video. VYRL is the ultimate content creator tool. No content creator is going to be able to post their videos without using this. We're currently already at a 65% success rate. It'll predict the exact numeric view count that your video will get 65% of the time, and then it's within a standard deviation range the rest of the time. It is an incredible tool. I'm so excited to be launching this. Go check it out. Link in my Instagram bio and link in my YouTube bio. Anyways, for this problem, we're given a string called s, and it consists of lowercase letters and a 2D integer array called shifts. Shifts of I will contain a start, end, and direction. So for every element I, we want to shift the character in s from the index start to the index end, inclusively forward if directions equal to 1, or backwards if the directions equal to 0. So for each shift, all the letters in the range from start to end are shifted by one position, either forward or backwards in our alphabet. After applying all of our shifts, we want to return our final string, and keep in mind that we will be, if we're at Z, we might and go right, we'll go to A, and if we're at A and go left, we'll go to Z. So multiple shifts can apply to the same character. First thing we're going to do is, I am going to do this in Python since I have been doing a lot of machine learning projects, is we're going to take into consideration our intuition. So we want to efficiently apply multiple shifts across ranges in the string. So we want to naively process each range, and that would take too much time. So we're going to handle our cyclic shifts in the alphabet using a prefix sum technique. So that way we don't have to recalculate every single range. So here's our step-by-step plan. Step 1 is we are going to use a prefix sum to record the cumulative effect of all shifts on the string. So before we even do anything, we're going to calculate how each shift affects our string. Then we can compute the actual shift for each character by calculating the cumulative sum of prefix sum. So we will first calculate all the possible shifts, and then we'll go through and apply each shift and get the sum that would have come from that calculation, because we already calculated it. And then we will simply apply these shifts to our string. It's as simple as that. So I'm going to go ahead and write down our steps in the order we're going to complete them so we can base our code off of that. So let's go ahead and dive into this code. First thing we're going to do to make our lives a little bit easier is assign a variable the length of our string s. Then we can use our prefix sum and define that as an array. So to do that in Python, we're going to define the value that's going to be consistent in all of our cells. So we're going to start with 0, and we're going to have a total of n plus 1 cells in our prefix sum array. So that's initializing our prefix sum array. It is going to be cells of 0, n plus 1 amount of those cells of 0. Now we're going to record the shift ranges in our prefix sum array. So for each variable start, end, and direction in our shifts array, because those are the three elements, we have start, end, and direction, we can assign a value equal to 1. This is going to be the direction we're moving. So we're either going to move forward or backwards. So value is equal to 1 if direction is equal to 1. Otherwise, so else, value will be equal to -1. So I'll determine the direction we're moving. Then we can update our prefix sum using that direction. So prefix sum of our start value will plus equal the current value. And then we can do the same thing for our end. So prefix sum of our end plus 1, because it's inclusive, will minus equal our value. So how exactly does this work? We are going to take all the values of our direction, meaning if we're going to move forward one or we're going to move backwards one, and we will pre-apply them to each element in our start and end in our prefix sum. So let's say we get to doing our array, and this is how it looks. So 0, 1, 2, 2, 1. This is just an example, but we can take a look at this and say, okay, our character at here, we'll do length 4 so we can compare it to DZ, TZ. So we have DZ, TZ. And basically what we're going to do is we already have the changes defined right here. So character at index 0 is going to change 0. Character 1 is going to change once. So Z is going to go to A. So now we have D, A. T is going to change twice. So T is going to increment by 2, which means T is now going to be V. And then Z is going to change twice forwards, so it's going to be B. And that's it. That's our output. So we're going to pre-compute for each index how many times they need to change and in what direction. And that's all we have to do for step 1. Step 2 is we're going to compute the cumulative sum in our prefix sum array. So for I in our range, starting from index 1, going to index n, because our index 0 of a prefix sum will always be 0, our prefix sum of I will plus equal the prefix sum of I minus 1. So we're always going to get the previous element as well. And sorry, not all prefix sums at index 0 will be 0. We just don't want to go out of bounds negatively because we are going to be collecting the previous element as well. And that's all we have to do for step 1. We're going to compute our cumulative sum in our prefix sum array. Next thing we're going to do is apply the shifts to our string. So simply we'll take a results variable and we'll equal that to a list of S. So we're going to turn S into a list. So now results is a list of the characters in S. And so for I in range N, now we can say total shifts will be equal to our prefix sum of I, and our total shifts will once again equal total shifts modulus 26, so we don't go out of bounds, plus 26 to get the correct character, and once again modulus 26 to not go out of bounds. So that is going to handle negative shifts. So in the case that a number computed up here is negative, this will handle negative shifts, ensuring that we stay within our alphabet range, basically. Now we can compute the new order of our characters after applying our shifts. So we'll define a new character. It'll be equal to the order of S of I minus the order of our character A plus the total shifts made modulus 26 to stay within the alphabet's range. And then we will use our results of I, because it's a list, and we'll make sure it's a character, order of A, plus our new character, to ensure that it is stored as a character value, not as a number value. And that's it. Now we can simply return an empty string and join that string with our results list, turning that into a string as well. So if we run this, passes our test cases, and if we submit it, passes passes all solutions. So the time complexity for this is O of n plus m, where n is the length of a string and m is the number of shifts. This is because we process the shifts in O of m time and compute the cumulative sums and apply the shifts in O of n time. So that's it. Thank you, and follow for more daily LeetCode solutions and check out VYRL, link in bio.